Okay, so these are going to be examples like the homework, but not the homework. So the first couple problems, or the first problem, has to do with if I give you two triangles and I give you some dimensions that you can figure out all the 6 trigonometric functions as long as I give you two sides of the triangles. So let's say I give you, let's say this is the angle theta, and we have the same angle theta over here. And let's say I give you the two sides. So let's say this is 2 and this is 3 and this is actually let's got to make sure these are make sense. So let's say this is 2 and this is 3 and this is 4 and this is 6. So I've given you both the opposite side and the adjacent side. And we know that theta is the same angle because these are similar triangles because of the fact that these are the same ratio. So 4 divided by 6 is the same as 2 divided by 3. And what they're asking is to find the exact values of the trigonometric function for the particular angle. So we only have to really do it for one of these triangles. So to find the length of the third side of a right triangle, then you have to use the Pythagorean theorem. The Pythagorean theorem is only good for right triangles. So what we say is 2 squared plus 3 squared is equal to, we'll call this h squared. So that's 4 plus 9 is equal to h squared. H equals the square root of 13. So we add these two together to take the square root. Okay. Now, basically what we have is we have the length of the opposite side, and that has 2 units. The adjacent side is 3 units, and the hypotenuse, I'll use a capital H here, the hypotenuse is the square root of 13. So to find it, it's basically using SOHCAHTOA. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. And so we can find the exact value of the sine of theta by taking the length of the opposite side over the hypotenuse. So that's 2 divided by the square root of 13. And if we multiply and divide by the square root of 13, we get it in that form. Let's go ahead and do the cosecant. So the cosecant is hypotenuse over opposite. And what we'll do is we'll take the non-simplified version here because it makes it easier to do the reciprocal. We just flip the numerator and the denominator. Then you have the cosine of theta is the adjacent over the hypotenuse, and the adjacent is 3. The hypotenuse is the square root of 13. So again, you can multiply and divide by the square root of 13 to get that form. So we can do the secant of theta, that's the hypotenuse over the adjacent, and so you get the square root of 13 over 3. It's kind of like what we did in the previous section, except there we used x, y, and r. Here we use opposite or adjacent opposite on hypotenuse. Okay, then you got the tangent of theta, that's opposite over adjacent. So opposite is 2, adjacent is 3, and the cotangent of theta is adjacent over opposite, or 3 over 2. And the question explain why the function values are the same. It's because the angle's the same, and the angles are the same because they're similar triangles. They have the same length of each side. Well, actually, they don't have the same length. They have the ratio of the lengths are the same. Okay, and notice all these trig functions are positive, and that's because you always get trig functions positive when you're dealing with right triangles, because you're dealing with just positive lengths. Okay, the next kind of problem, you're given one of the trig functions, the cosine of theta, the sine of theta, tangent of theta, where they give you two sides. So let's say they give you 5. So the cosine of theta is 5/7. And since this is a right triangle, we know that we don't have to worry about the sines. They're all going to be positive. So theta is this, and the cosine of theta is 5 opposite or adjacent over hypotenuse. So you'll get, using the Pythagorean theorem to figure out what this length of the third side is, you'll have 5 squared plus x squared equals 7 squared. X squared is equal to 7 squared minus 5 squared, which is 49, minus 25, which is 24. So x equals the square root of 24. And we could say that's 2 times the square root of 6. So, 24 is 4 times 6. The square root of 4 is 2. So you could put it in that form. So now we've got all three sides again. So now we can use, we can find the trig values for all the other trig functions for this angle, or the angles associated with this definition. So the sine of theta is opposite over hypotenuse. So opposite is 2 times the square root of 6 divided by the hypotenuse, which is 7. I can't really simplify that. Before we move on, let's go ahead and do the secant of theta. That's going to be 7/5 because the cosine is 5/7. Okay, now we can go ahead and do the cosecant of theta. That's going to be 7 divided by 2 times the square root of 6. And if we multiply by the square root of 6 and divide by the square root of 6, you'll get that. And so you can get 7 times the square root of 6 over 12. Make sure I did that right. Okay, and then you have the tangent of theta, which is opposite over adjacent. Opposite is 2 times the square root of 6 divided by 5. Can't simplify that any further. And the cotangent of theta is adjacent over opposite. So you get 5 divided by 2 times the square root of 6. And again, you can multiply the numerator and the denominator by the square root of 6. So you'll get 5 times the square root of 6 over 12. So that's the cotangent of theta. So let's do one more. Let's say I give you that the tangent of theta is equal to 2. So the tangent is the opposite over adjacent. So I can make my right triangle using that. So 2 is the same as 2 divided by 1. The reason I do that is that I can say the opposite side length is 2 and the adjacent side length is 1. And so the hypotenuse is the square root of 5. 1 squared plus 2 squared, which is 1 plus 5. Take the square root. So that's that. Now, again, we can do the cotangent of theta easily. It's just going to be 1/2. It's the reciprocal of that. Let's do the sine of theta. Sine of theta is opposite over hypotenuse. Opposite is 2. Hypotenuse is square root of 5. If we multiply and divide by the square root of 5, we'll get that. The cosecant of theta is hypotenuse over opposite, so we get the square root of 5 over 2. Sine of theta is adjacent over hypotenuse. Adjacent is 1 divided by the square root of 5. So that's the square root of 5 divided by 5. And then the secant of theta, which is hypotenuse over adjacent. Just take the reciprocal of that. We'll get the square root of 5 over 1, which is square root of 5. Okay, so that's how those problems work. Now the next thing they do is they give you two pieces of information and ask you to find the trig functions of the other trig function, or the ones they're asking for. So if you get you know, the sine of 60 degrees equals the square root of 3 over 2, and the tangent of 60 degrees is square root of 3, then they might ask you for the other things. So if they ask you for the cosine of 60 degrees, how would you do that? Well, one way is, of course, is to draw a triangle. Say this is 60 degrees. That's the square root of opposite over hypotenuse. So if you take, if you use the Pythagorean theorem, you'll have 2 squared plus x, well, 2 squared is equal to, the hypotenuse squared is equal to the square root of 3 squared plus x squared. This is my third side. So you get 4 is equal to 3 plus x squared equals 1, x equals 1, so this is 1. So, you know, for 60 degrees, I can find all of the trig functions. Because as far as 60 degrees, this is the opposite, this is the adjacent, this is the hypotenuse. So the cosine of 60 degrees, which is adjacent over hypotenuse, is 1 over 2. You get a half, which is not surprising based on what we've seen before. If you wanted to do the cotangent of 60 degrees, then that would be adjacent over opposite. So the adjacent is 1, the opposite is the square root of 3, which if you rationalize it here, you get the square root of 3 over 3. Now if I ask you for the cosine of 30 degrees, well, one thing is, you know that this angle here is 30 degrees. If this is 90, this is 60, that has to be 30. So you just have to figure out which is the opposite side relative to the 30 degree angle, so the adjacent side. So you got adjacent over hypotenuse still. But in this case, the adjacent is not this side. The adjacent side is the square root of 3. The hypotenuse is still the same. So you get the square root of 3 over 2, which makes sense. If the cosine of 60 degrees is a half, the cosine of 30 degrees has to be the square root of 3 over 2. So that's how you can find, you know, if I asked you for what the cosecant of 30 degrees was, that's cosecant is hypotenuse over opposite. It's the reciprocal of the sine. Sine is opposite over hypotenuse, so it's hypotenuse over opposite. And then you look at your triangle and say, oh, 30 degrees, that's this angle. So what's the opposite side? The opposite side is 1 relative to the 30 degree angle, and 2 is the, oh, sorry, the hypotenuse is 2. So the hypotenuse is 2, and the opposite side is 1. So you get the cosecant is 2, which should be the reciprocal of the sine. And that's why if you see this thing, you know, the sine of 90 minus alpha? Well, if in this case alpha is 60 degrees, then 90 minus alpha is 90 minus 60, which is 30 degrees. Okay, so the second problem in the homework gives you, instead of giving you the angle, it tells you that the cosine or sine is something. So what I'm going to do is I'm going to say the sine of alpha is my example to help you solve this problem. Let's say it's 2/7. And if I wanted to know what the cosecant of alpha is, let's say I want to know what the cosine of alpha is and the cotangent of alpha. And then finally I want to do the tangent of 90 minus alpha. Okay, so I want to find the exact value. So again, what you're going to do is you're going to create a right triangle. And this triangle is going to have a reasonably small angle based on these numbers here. So let's call this alpha. So opposite over hypotenuse, and that makes the adjacent side. So to get the adjacent side, you're going to say 7 squared is equal to x squared plus 2 squared. So this squared is equal to that squared plus that squared. So you'll get 49 minus 4 is equal to x squared. 7 squared is 49. 2 squared is 4. So you get x is equal to the square root of 45. Okay, so that's the square root of 45. So the cosecant is hypotenuse over opposite. So relative to the angle alpha, the hypotenuse is 7 and the opposite is 2. And that makes sense because you got, the cosecant is the reciprocal of the sine. Okay, the cosine is adjacent over hypotenuse. And the adjacent is the square root of 45 divided by the hypotenuse, which is 7. Which we can just leave as it is. Okay. And then finally, the cotangent is the adjacent over the opposite. The tangent is opposite over adjacent. So the adjacent is the square root of 45 over the opposite, which is 2. Now, to do the tangent of 90 minus alpha, this angle here is 90 minus alpha. Because this is 90. 90 plus alpha plus 90 minus alpha is 180 degrees, so that has to be 90 minus alpha. So all you have to do is know this angle is 90 minus alpha, and so for the tangent, again, tangent is opposite over adjacent, but in this case the opposite is this side and not that side. So you get the square root of 45 over the adjacent, which is 2. And you can see here that the cotangent of alpha is the same as the tangent of 90 minus alpha. That's, I think we looked at that in the previous section. The sine of alpha is equal to the cosine of 90 minus alpha. The cosine of alpha is equal to the sine of 90 minus alpha. The secant of alpha is equal to the cosecant of 90 minus alpha. Then you've got the cosecant of alpha is equal to the secant of 90 minus alpha. The tangent of alpha is equal to the cotangent of 90 minus alpha, and the cotangent of alpha is equal to the tangent of 90 minus alpha. And that the whole idea here is you only need if you have a table, you only need them from 0 to 45, because you can always get the angles between 45 and 90 by using these formulas. If you're using tables, which we don't use tables anymore. Okay. Next part says evaluate the trigonometric function by memory or by constructing an appropriate triangle for the given angle. So the example, the homework example is 45 degrees. Let's say, the sine of 60 degrees. So if we memorize them, but let's not memorize them. It's one of these special triangles, 30, 60, or 45. So I'm going to make the angle bigger than 45, so that's 60. And remember, how did we get this? Well, we had an equilateral triangle, not equilateral, I guess that is it. Yeah, equilateral triangle. So we cut the equilateral triangle in half. So this is a half, this is 1, and if you use the Pythagorean theorem, you'll find out this is the square root of 3 over 2. So that's kind of how you'd remember. At 30 or 60, you take an equilateral triangle where each angle is 60 degrees. You make each side of the equilateral triangle 1. So when you cut this in half, one side, if you cut one side in half, the length becomes a half. And then you can use the Pythagorean theorem. It says 1 squared is equal to 1/2 squared plus x squared. 1 is equal to 1/4 plus x squared. Subtract a quarter from both sides. Take the square root. And you get the third side is the square root of 3 over 2. So once you've got that figured out, you can do any trig function. So, the tangent of 60 degrees is opposite over adjacent. The opposite is the square root of 3 over 2. The adjacent is 1/2. So cancel out the 2's and you get the square root of 3. Okay, so I'm not going to do that. Okay, the next thing is doing some trigonometric identity problems. So let me find some that are not the ones that I assigned for the homework, but ones that I don't make up, so I get them right. Okay, so let's say I give you tangent of theta, cotangent of theta equals 1. So what we're trying to do is prove that this is true. And so, how do you do that? Well, you could, the trigonometric identities up to this point are, the reciprocal relationships or the definition of these. So there's two ways of doing this. You could say the tangent of theta is the sine of theta divided by the cosine of theta, and the cotangent of theta is the cosine of theta divided by the sine of theta. And if you substitute those in, you get the sine of theta divided by the cosine of theta for the tangent, and you get the cosine of theta over the sine of theta for the cotangent. And you see this cancel out with that, and that cancels out with that, and you get 1. And that proves it. The other one is that the cotangent is 1 over the tangent. So there, those cancel out to be 1. So those are the two ways, the two types of trig identities. Let's just do one more. So let's do this one. Secant of theta plus tangent of theta times secant of theta minus tangent of theta equals 1. So what you do is you use FOIL, and you would get secant of theta squared, secant of theta times secant of theta squared. You do the outside, which would be negative tangent theta times secant theta. So it's this times that. And then you'd have the inner, which would be tangent of theta times secant of theta. So this times that, and you can see those cancel out. One's plus, one's minus. And then you have minus tangent of theta squared. So you got negative. And we could rewrite secant of theta squared as secant squared theta. It's just a more compact form. Do the same thing there. So you get that result. And there's a trig identity involving the Pythagorean identity. So there's, if you look in your book, you'll see that the tangent, or the secant squared of theta, so let's substitute for the first one. So you get secant squared of theta is equal to 1 plus tangent squared of theta. So that's the substitution here. We leave the second term the same for right now. And you can see that cancels out with that, and all you're left with is 1. So you get 1 equals 1. So that's how these go, and we're gonna spend a lot more time on them in chapter 5. And the final kind of problem you're going to have are examples, or what do you want to call them? Just practical problems. And they're all involving right triangles and similar triangles. So what I have here is I have a lamppost and then you have some person standing out here. And the light shines and it goes straight, and then it creates this shadow. So you got this shadow that's on the ground, and it's probably going to be, just dark. It's not going to show any details, but so it's kind of fuzzy, of course, but it is a shadow. And the question is, what is the height of the lamppost? If the person is 6 feet tall, and the distance from the lamppost to the person is 20 feet, and the distance from the person to the shadow is 10 feet. So the question is, what is the height? And there's two ways you can do this. You can do it using similar triangles. The other way is to notice that these two triangles. So here's one triangle. So that's the one triangle. And then you got the bigger triangle. So they both have the same angle theta. So I'll show you both ways of doing it. One is you can say that the height of this triangle to the base is the same as the height of this triangle, the bigger triangle, to the base, which you got to add the two together. So the base is this whole thing, 20 plus 10. So if you do that, you'll get 6 over 10 is equal to h over 30. Cross multiply, you get 180 is equal to 10h, or h is equal to 18 feet. Okay, so that's the height. That's a pretty tall lamppost. Okay, so that would be one way of doing it. The other way would be to say, the tangent of theta is the opposite over the adjacent. And what we do is, for this small triangle, the opposite is 6 and the adjacent is 10. So that's the tangent, but that's also, so this is for the small triangle. But that's also the angle associated with the blue, so you get the opposite. I'll say for big, opposite over adjacent for the big. So what you'd end up doing is the the opposite side for the big is h, and the adjacent side for the big triangle is 20 plus 10. You see you get the same basic equation, so you solve for it and you get 18 feet. So one way is just to not even deal with trig functions. One is to find the trig function, the value of the tangent of theta for the smaller triangle, and then use that same angle applied to the big triangle. So I think that's all I'm going to say about those. So those are some examples of the problems that are similar to the homework assignment.